Welcome to Fresh Thinking. Today we'll be talking about a presentation given by Tarrant Elkington on extending the use of generative AI tools into the area of coding so engineers and scientists can create prototypes to help them with their work. I'm your host, Susan Havlin, Managing Consultant for the Geology team in Australia for Snowden Optiro, is our General Manager and Mining Engineer. Welcome, Tarrant.
Thanks, Susan. Great to be here.
So what was the motivation behind the presentation you gave last week?
Well, firstly, I was just trying to think of something to present, but I was trying to think of what's a relevant topic for people in the industry at the moment to try to learn about, and like everyone else, trying to learn how to use generative AI tools and how it applies for the industry, and probably like everybody else used ChatGPT or Copilot for the usual things, summarizing reports and helping gather knowledge and all of those sorts of things that people tend to do. But I started to dabble in another area of use of AI, which is in coding. And I remember, like we talked maybe a year ago, and people wanting to learn, people needed to use Python or something like that to, I guess, stay current and in the evolve with the industry, and this was actually a topic that would help you develop things in coding like Python or whatever, so that you can develop your own solutions. So I guess that's the rationale. At the same time, like, I've always been interested in developing software or developing bespoke tools for use with our clients. So this was a way that I think that engineers and scientists could actually use this in their everyday work, in order to take whatever they're doing to the next level. So it's really just trying to raise awareness that mining engineers and scientists can do coding to an extent now with these generative AI tools, and how you can go about it.
So how does it actually work? Like, could I do it?
Yeah, of course you could do it. So So I guess the area that we're talking about, sometimes people call vibe coding or whatever, but it's generally taking an AI tool, describing a business problem to it, and then asking it to generate the code to be able to do that for you. So you give it all of the inputs, you give it the outputs you expect, and if you want to explain a little bit about how you want it to do it, then it will follow that. And after a bit of effort, and then ultimately it will produce code for you in whatever language that you ask it to provide, which you can then go and run in any like development environment. And so really all you need then is somebody that, like an engineer or somebody with a business problem you're trying to describe, like an AI, generative AI tool, which might cost $30 a month, and a development environment like Jupyter Notebooks or VS Code, which is ultimately free. So it doesn't take much for you to get started. And the first time that I did this, I literally gave it like a 1-paragraph description of what I wanted it to do, and it produced the code for me.
Oh, that's cool. So have you got some like examples of where you've used this?
Yeah, so there's used it for quite a few things, and of course everybody's own examples or own business problems will be specific. Generally, I'm thinking to use it for things that, say, the software doesn't do for you, or the general software doesn't do for you out of the box. So things that you haven't been able to solve with existing software, either because it's a very niche problem or specific to a certain site and you want things done in a certain way. So I guess a couple of the examples was that I was seeing regularly in our consulting work was trying to find a path down from the top of a steep mountain, a pioneered road, or a path for a pioneered road from the top of a mountain to the bottom to minimize the cut and fill, because I knew there were algorithms that I don't really understand specifically myself, but it could identify to be able to do that. And so like we were able to use that to potentially take something that somebody might need to do manually to try a scenario might take a day or so, to generating it in a few seconds and having it, following the most optimal profile. And we used it for other examples where it identified opportunities to maybe halve the construction cost and time to develop one of these roads. So that's an example. We've also used it to, I guess, help understand some academic papers and some logic in academic papers for running things like machine learning, resource estimation, or like you could use it in any other application like that. Used it for trying to figure out where to put waste dumps, how to minimize the cost, how much space is available for waste dumps, and then other bespoke little widgets that I've developed for specific applications.
So does it usually just work? Like, are we like, how long would it take you to write one of these things?
That's a good question. So sometimes, if you, as I've gone through it, you improve the way you describe the problem, and generally, if it's a simple problem, it might just work the first go, and that's like, hallelujah, fantastic. But it doesn't always happen, and so the more complex the case is, then often it will produce bugs. Firstly, produce bugs, right? So you can just feed those bugs back into the generative AI tool and ask it to try to resolve it. Copy and paste it in, yeah. So, and it will try to identify the issue or update the code, and then you can reuse the code and see how it goes. So the first thing you got to do is get the program to run. And then once you've got it to run, of course, you need to check to see that the results make sense. So we can't just rely on these tools and blindly. We need to make sure we've described the problem and that the output that we're getting is something that we would expect and is, and is correct. That's our job, to do that. So there's the two steps: getting it to work, and then getting it to work in the way that you want it to do. And so it can take anywhere between a few minutes to run through the whole process to a few days, depending on how well you describe it and the complexity of the problem.
Great. So did you learn anything through this process?
Yeah, I learned a lot of stuff during the process. So I guess one thing you learn is I don't really know those coding languages, but you do get to learn a bit about them. It also does force you as a engineer or scientist to better describe the problem that you're trying to solve, which sometimes is not always easy to articulate clearly. But when you're telling it, I want it to do this, and I want you to use this, then you need to be able to articulate that, which is a good process in itself. I think you need to be persistent, so it's not a magic wand. It's a tool to help you achieve a certain outcome.
Yep.
So and I think you really need to think about what it is that you're trying to achieve. So that's what it will come to a laser focus of. It can produce a result, but do you know really what's the optimal, what's the best solution, and try to guide it towards that.
So is there any circumstance where it just hasn't worked?
There's circumstances where it's particularly hard. Like you could describe a problem that's actually, nobody solved in academia, right? It's probably not going to figure that out for you straight away or at all. So it might send you into a loop that you will never come out of. So I think you need to be realistic and say, I'm only going to try to solve part of a problem, a specific problem that can be well defined, and that there's potential solutions for. We're not looking to use this to solve the most complicated problems that all of the minds in the industry have never solved themselves. So I think that's one thing you need to be aware of, but it's probably going to be optimistic about its ability to solve these problems too. So you just need to know maybe when to cut your losses a little bit on that. So and how to be realistic about it.
So what you're saying is maybe start small.
Yeah, I think start with a small, specific example that you want to solve, and just get the training wheels, um, and then work through from that point into something that's more complicated.
Great. So what would you recommend to engineers and scientists listening?
Well, I think the main thing is just to give it a go, because I think the biggest impediment to doing this is actually trying. Um, so, and that was the same for me. Oh, can I be bothered? I've got to set this environment up. I've got to do this. It's going to be hard. So I think the first thing is just to rip the Band-Aid off. It's easy. Like I said, if you've got a ChatGPT or Copilot, Gemini license, you can use that. And the development environments are free, so you don't need to buy that. And if you want help getting set up for it, just ask the AI tool to give you a list of instructions of how to do it. So that's probably the biggest thing, is just to give it a go, because I think that in the future we really need to have this tool in our toolkit to do our jobs and to be more effective. I think with the use of these tools and AI, we potentially can become more effective and efficient. But then the bar is going to be raised as to what we're expected to be able to do in a day or in a week or in a month. So we need to have these tools in our toolkit to be able to do to keep up and also to keep ahead.
Well, thanks, Tarrant. That was really interesting. I might actually try and give it a go myself.
Great.
If you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you can find them for free on our website, Apple Podcasts,
Google Podcasts,
and most other podcast platforms.